the other and vice versa. Because you know that whatever the answer is to this one, it's the opposite of the answer to that one. Everything that solves this will not solve that. Everything that, does solve this will not solve that. Vice versa. All right. Let's do another. But please notice that there is a great asymmetry between the less than problem and the greater than problem. The other thing I always try to tell students is with the absolute value problem, most times you're going to get two answers. If you just have one answer, what probably happened is what for the equals problem? You probably just forgot to do the minus one, right? A lot of times I see students on tests, they're doing absolute value equals something. What do? They just drop the absolute values and solve the equals to the plus thing. And they get an answer, right? But that's half the answer because there's also the minus case, right? Just saying, that's usually the mistake. Here, let's work another one here that's a little bit more tricky. Not really much. Absolute value of, let's see here, 10 minus 3x plus 2 greater than 1. Well, let's make that a 9 there. If I made it a 1, then that would say that the absolute value is greater than minus 1. And that's true, but the answer is just everything. Okay, so, I guess, fine. Let me go back to that for just a second here. That's a good example, actually, because this could happen. Would this be 10 minus 3x greater than minus 1? Is that true? How about this? Is minus 1 greater than 0?
No.
Oh, it's not. Rats. Let me write this a slightly different way. I don't know why. This just, it helps me to write it this way. Minus 1 is less than 0, right? That's true, which is less than or equal to 10 minus 3x, right? So my point is that the solution to example 10, as I stated it, is just what x solves this. See, it doesn't matter what you put into absolute value. It's greater than or equal to 0, right? No matter what x you put in there, it works. The answer is solution. Solution set is everything. We don't need to use the boxes or anything. We can just, this inequality right here shows that it's true. Yeah. Oh, if it was equaling a negative, you're right. That would be game over, end of story. But this is greater than a negative.
Okay.
Now, if you could turn that inequality the other way, right? If that was less than instead of greater than, I'd be on board with you. We can't have the inequality. We can't have absolute value less than minus 1, because that would mean that it's not greater than 0. Yeah. So let me make it more interesting. Example 11. Sorry, I got distracted with my own example. My bad. So 10 minus 3x plus 2 greater than, I think I had 9 there. Let's try that. So first of all, clean things up. This gives us absolute value of 10 minus 3x, right, greater than 7. All right. And we have to unwrap this as a pair of inequalities, right? So we have 10 minus 3x less than minus 7, or 10 minus 3x greater than 7. No equality here because it's strictly greater than this problem, yeah? Now I do what? You got different choices. Personally, I kind of like to add 3x to these. Because if I add 3x, then I don't have to divide by minus 3. So what do you want to do? Do you want to isolate the minus 3x, or do you want to move 3x to the other side? Isolate it? All right, I will isolate it then. So we'll subtract 10 from both sides on this one. And I will subtract 10 from both sides on this one. That will give me minus 3x is less than minus 17. And this will give me minus 3x is greater than minus 3. Now, we got to be careful. When we divide by minus 3, what happens? We got to flip the less than to greater than on both of these, right? So divide by minus 3. We get minus 3x over minus 3 is less than minus 17 over minus 3. And minus 3x over minus 3 is greater than minus 3 over minus 3. Am I right? Am I wrong? You're like, why don't you just do what you said, right? What have I not done? Why is this wrong as it's written?
You haven't like simplified?
No, well, that's part of it, but lesser of an issue. The issue is when we divide by minus 3, we have to change this to that, right? Greater than becomes less than when we divide by minus 3. So don't forget to flip the inequalities. With that, now we have x is greater than 17 over 3, or x is less than 1. And so our solution set is, let's see here, 17 over 3 to infinity, unioned with minus infinity all the way to 1. Now, you might wonder, is that okay? Can I put the 17 over 3 to infinity first, and can I put the 1 to infinity, minus infinity to 1 second? You can. Like the union, A union B is equal to B union A. Like union is commutative. It doesn't care which order the set goes in. In contrast, I really should not write 1 to minus infinity. Like that's not allowed, at least in this course. So, any questions? So I wanted to warn you, if we are up against something where we got a minus inside the absolute value, when you do one of these, you still got to remember that thing we did last class about flipping the inequalities, okay? That's it for our set of examples. Is there a particular like homework problem you guys want to talk about in the time that remains? I saw something in the homework that looked a little different than any of my examples so far. Maybe I should hit that one. Let's see here. Find it. All right, here's one. I think there's basically two issues with the homework that haven't been addressed in the examples that I've done in class. The one is that sometimes the inequality comes to you in the wrong format, so you have to reformat it. That's this one. So here you're asked to solve 5x squared plus 17x less than or equal to 12. This is my, this is like number 8. So this is example 12. This is like number 8 in the homework. So if you're up against this, what do you got to do? Or here's another one. So I'm not going to solve these to the end. I'm just going to give you like some advice on how to get started, okay? This one's another one. This is like number 12. This one is number 13. And it's kind of the same issue with all of these, actually, which is that they're not in the setup that we had to start with. What makes these different than the problems we've worked in here this week? They're not compared to 0, right? So the first order of business is to make them fit the format we know how to solve, which is pretty easy for this one, right? So we just do 5x squared plus 17x minus 12 less than or equal to 0, right? And then you can go to town on that. I think this one factors. Now your problem's probably going to have different numbers, right? So but I think this might be one of those factoring ones. Like, yeah, minus 3 plus 4. There you go. So I think your problem will likely also factor. What are the critical numbers? So minus 4 is obvious from this one. But the critical number here we have to think about for a second. It's actually 3/5. Right? And then past that, you draw the number line, you test your points, right? And so forth. How about this one? 12 over x plus 6 less than or equal to 2. What I would do here is I would trade this problem for the one with 0. Right? Now then what do I do? We haven't done anything like that. What should you do? Make it look like the problems we've solved, right? So this is the same as 12 minus 2 times x plus 6. You got to make a common denominator, right? And then you want to clean it up, right? And then you can see that the critical number is minus 6, and upstairs, what happens? So if you look at that, you can see what are the critical numbers. 0 and minus 6. And then you put them on the number line, you test each point, then you can solve the problem. Yeah? Again, this one is not the format we want. We want x plus 2 over x minus 7 minus 1 less than or equal to 0. That problem we can solve. So we make a common denominator. X plus 2 minus parentheses x minus 7 divided by x minus 7, which is, by the way, what? The x's cancel, and I think what we got is 9 over x minus 7 less than or equal to 0, right? So you can, any of the problems you have in the homework, you can reformulate them with a little bit of algebra into the problems we've solved this week, right? Which are comparing either a rational expression or a polynomial to 0, right? That's the nonlinear case. Of course, the other was the linear inequalities. Those are what we did to start with. But, let's see here. The other, here one last problem here. 15. If you got x plus 7, 2x plus 8. 3x minus 6 greater than or equal to 0. What are the critical numbers for this one? I've reduced the cognitive load of our examples by not having like these numbers here, right? Those have not been present in my examples up to this point, have they? Not really, right? But it's easy enough to deal with them. So this is minus 7. When we solve that equal to 0, we get minus 4. Solve this equal to 0, you get minus 2, right? So if I plug in minus 4, that gives 0. What I'm doing is I'm just solving 2x plus 8 equal to 0. What's that give me? Right? If I solve 3x minus 6 equal to 0, I get, oh, not 2, not minus 2, what? No, what should this be? Positive 2, yeah. Those are your critical numbers, and then you can use the method. So if you want to see more examples of the things we haven't done this week, I'll be doing more of those in like the Monday, Wednesday, Friday section. So if you thirst for additional examples, just watch one of the ones from tomorrow. Or send me an email. It's all good. Thanks, guys. Guess I should stop recording.